Let's see, in this video we can go through the create request HTTP higher level client library in Rust. So we can create HTTP clients and um, can do get request, post request, and we can do JSON format, plain bodies. A lot of options are there. Um, so it's a high level HTTP library. So a lot of things are abstracted for us. But in this video, let's see how this crate is created in Rust. So let's go to the GitHub repository, and we can see before that, let's do let's do a quick overview how to call a get request. So for starting with uh, request, we need to add request create as dependency, and we also need Tokyo because our get requests are or post requests are async, so we need a runtime to run the request. And if you are planning to work with JSON response, probably we need certain JSON as well as a dependency. Having said that, so we can go to an example code. So in this example, we are declaring Tokyo main. So this procedure the procedure macro will create a runtime for us. So if you want to see the code, let's see whether, yeah, see, this is the procedure macro attribute, and this is the main function. This is inside Tokyo library. Yeah, and we are calling an async main function. So inside this, yeah, we are defining an async function that will be running in that Tokyo runtime. So in this async function, we are returning a result box std error. So we can handle the result as unit type as well as any error which can implement standard error. The standard error is a trait under standard library, Rust library. And first, let's ignore this. There are two ways we can create a get request. So first, let's see, we can directly use a get request from this module. So this is the request library, and that we can see a get request, a async function. So if you see where it is, it's inside lib.rs async impulse async sync. Okay, that's what is showing here. But let's go to the code and lib.rs. They are using a lot of HTTP library modules, functions and methods. That's okay. And they have created requests its own error module. if you want to see that, it should be error. So this is what error module is. It will be a separate file. Going back to lib.rs. Yeah, mod error, mod into URL. Okay, this one. Mod response, self error error. Basically, it's defined its own error, but that is std error itself as std error. Okay, fine. And this is our function. This is what we are seeing in here. Async get, async append get. Is into URL. Any type can be converted to URL. Yeah, that's what we are giving. So basically, string is can be converted to URL. Yeah, it has its own response, and basically it's calling client builder build dot get dot send function. So let's see what is that here in our visual code. In other ways, I just want to show that here as well. So client builder, so this is a request client, it's struct, and a client, an asynchronous client to make request with. So the client has various configuration values to tweak, but the default are set to what is usually the most commonly desired value. To configure a client, use client builder. So that's what they have used here, client builder dot build. Build client builder. Client builder will create a client builder type. So this is builder function is creating a client builder type. And client builder can be used to create client with custom configuration. So we are calling a build function on that will create a result client. Okay, it's a result client. So basically, this is our code. Yeah, build. We are getting a client here, and we're calling a get method on that. So let's see where is the get method on that. Result client. Yeah, we have a get method on the client, and that will return a request builder. Okay, request builder. Request builder should be able to send. So where is the recording? Yeah. So builder dot build dot get dot send. So we need to know what is this request builder is. So request builder, a builder to construct properties of a request. So this is what the struct where we create a request. So we create, yeah, headers. We can set headers explicitly, basic auth, body, timeout, query. Yeah, all these things we can set up. So request client new client dot post the client dot post dot form dot send. So what is this send? Yeah, you can do JSON. So that's what we are doing in our sample program. Equals get here dot get dot send. Okay, send. So what is send? Send construct the request and send it to the target URL, returning a future response. So we have to do a wait on this to get the response, and the result will be result response. So question mark wait will do the give the response back. That's for that. So yeah, in this actual library lib, they're actually calling client builder dot build dot get dot send dot await. And how the client builder has, okay, before that I can just run this program. Not compile due to one previous error. Oh, this one. We got the response back with an JSON object with date and time. That's what this URL gives back as response. And if we need to comment this one is a client building example. So this example, we are creating a client builder, and we are getting a client builder, client dot build dot get. There we can give the URL, and send will send the request. So here we got the request builder, and we are sending the response request, and we are waiting for the response, JSON response, and awaiting on it. And this is a JSON value. Let's see what is value is. Value is an enum which can be null, bool, number, string, array, or object that can be mapped to string value. Yeah, basically all the JSON format can be mapped as a value. So that's the reason we are mapping to a value, and value can be printed also with debug print. So with that, we run this. Yes, we are getting the response back, the date object. And next thing what we need to see is how the client builder has built. So it's a struct with a lot of properties. This is a client struct, client builder struct, and there's a config. Config is another struct with a lot of properties. Accepts headers, the header map, host name verification, certificate verification, and if you look at timeout, TLS. So config is where we are configuring all the builder parameters for client. So here client is an arc client ref. What is client ref? It's a struct with similar kind of parameters. Why the client is different builder? Let's see what is new client builder. So it will build and it has a build parameter, so it's creating a client. Client is a client. It just need basic properties, doesn't need all the configs. Configs. So self.config, config.error if erroring, proxies, it has a connector user agent, HTTP3, TLS, different connectors. Pretty much lot of configurations. Connector dot new. So establishing a connection basically. This connector is a crate inside SRC. Okay, let's see what is that. It will be yeah, connector in HTTP implementation for different scenarios. Connection read. It's implementing read for connect. Okay, write for connect. Con is struct. This proxy member means it's a plain text HTTP proxy. This tells Hyper whether the URI should be returned. Okay, so we are using Hyper 2. Where are we using hyper here? Okay, so it's basically hyper read buff. Let's see, we can go to here, go to this read. Hyper, yeah, this hyper read. Um, this trait is similar to stdio read but support asynchronous reads. So they have written a separate read for in hyper. Attempts to read bytes into buff, read in test. Special read for hyper. Special rate write synchronous write. Okay, see, read buff. Basically, we are using hyper read here inside. Abstractions. Service connector response. Yeah, they are creating a service also for what is service. Where are we getting service? This is the into URL key URI. So basically, it's using into URL is basically using HTTP URI. So basically, request is using HTTP library and hyper. That's the main I can think of. So what is this hyper read? Let's see, we can hyper read we have seen. Connector. Okay, connector. Connector is what the main thing inside. Which client is implementing? We came to connector new. Oh, connector new is inside client. The way it is. Yes. Implement builder inside client builder. Builder standalone function. It's a standalone call. Connect. Oh, this is what it's returning. Client builder is returning connector new. This connector. Search string here. Find in files. Here is connector. Connector should be building a client builder. Yeah, should be building a client builder. Oh, new connector is doing connected. Okay, but new. So it will be getting HTTP connector proxy swag interface and basically returning a connector. Okay, connector. That's what the client also returning. Next connector. Okay, I want to see client builder here. Client builder. Okay, here. Next client builders. Okay, client is building from client builder. Agree. Debug for client builder. Yeah, here is the client builder. So client new function. Default client builder. Agree. Yeah, new. So yeah, new is building a client builder. Okay, agree. Okay. So next is build function. Build build function. Build is setting the config. Then finally it's creating a connector. Creating a connector from user agent. A lot of things are there and a lot of based on features. Okay. Yeah, this is what it's building connector. Connector it's building. This connector. Is it in the connector? What I want is yeah, not connector. Build function. It's creating a client. Actually, the builder is getting built in the client builder. So it's a hyper util client legacy client builder. So basically it's a hyper utility. We can set a lot of parameters, timer, full idle, and finally we are sending this client back with this inner arc new. Okay, so this is where the client builder function ends. Okay, that's good to know. Uh, but let's peek into this hyper utility. It's under hyper. Is it under hyper? This is, yeah, it's inside hyper utility src client legacy client.rs. Um, yeah, similar kind of stuffs happening here as well. Building a client builder, hyper RT executor. This is hyper util. Utilities for working with hyper. This crate is less stable than hyper. However, does respect Rust semantic version regarding breaking changes. Is hyper started hyper? src hyper. Go to the readme first. Hyper proactive and efficient HTTP library for all. Asynchronous design leading in performance. Okay. Hyper is relatively low level library meant to be a building block for libraries and applications. If you are looking for a convenient HTTP client, then you may wish to consider request. Okay. So basically a request is built with hyper. And I want to see the guide. Client. Oh, it has its own libraries. So there are also crates that provide connectors which result easy to use HTTPS for legacy client in util. Each has their own reason for existing, pros and cons, but this list is provided to help you get started. Okay, mention is hyperutil is used there. Let's see what is hyper documentation. Yeah, similar kind of document. HTTP connector new client builder. Okay, executor. Client.get. Yeah, so it's low level. You need to build insert docu executor and all inside this. This is little low level, but in request is high level. We just need to build.get.url. That will work. That's good. Okay, that's what request is. In hyper HTTP connector new. This HTTP library is HTTP header entry header value. So what is this thing? This is we are inside HTTP 1.1.0. Header types, HTTP header types. Module provides header name, header map, and number of types used for interacting with header map. Okay. So you have mode map, mode name, mode value. Map has all these things. These are all HTTP, I believe. Oh, these are map functionalities. Namespace, we have header name, value, header value, accept. Oh, these are all HTTP authorization. Okay, key, all these values. So I need to go to name, map. Let's go to name. Byte string, byte str, bytes mute. Okay, these are all standard. Header name is representation custom. Custom is a byte string, and is what is the is enum, standard and custom. Okay, header name. Okay, all these things are header name. Oh, okay, it's my previous standard header as string, standard header unsafe. It's checks generate constants for all standard HTTP headers. This include a static hash code for host hash path. Okay, accept, byte, accept. Okay, HTTP header content. Let's see. This state content length. Accept, accept. Yeah, see headers can have accept. Yeah. So this is what I think defined. Okay, this is understandable. Value. Same thing, a lot of standard and bytes, header value, bytes. Okay, how many? I think this value, I think this is what is mapped. Yeah, header value from hello. Header, you can see header. media type, content type. Mapping, it's mapping. Header value is bytes and yeah, okay. This header map is basically mask, indices, entries, extra values, danger. Is any type as value. D equals header value. Value is not use D. Okay. Extra values is header used to mask values to get an index. Hmm. A set of HTTP headers. Header map is a multi-map of header name to values. Mapping header name to values. Header name colon struct dot header name dot html example. Use header map. Yeah, headers dot insert host. This one. Okay, agree. Header name and value. Content length 1 to 3. Makes sense. Below you will find a fairly large amount of code. Most of this is to provide necessary function to efficiently manipulate the header multi-map. The core hashing table is based on Robinhood hashing, while this is same hashing algorithm used as part of Rus hashmap in stdlib. Many implementation details are different. Two primary reasons for this divergence are that header map is a multi-map and structure has been optimized to take advantage of characteristics of HTTP headers. Hmm. Yeah, yeah, yield value. This kind of a tuple, but so, again, intuitor, understandable, and values are the okay. Each value contained a header map will be yielded. Header map mutable value iterator. Okay, so HTTP is providing a lot of functionality on these variables to navigate. So why we came here? Okay, we came here from this hyper. In request itself we are directly using HTTP header. Okay, that's cool. What is URI? URI is another module. HTTP you under HTTP mod create. Yes, mod authority builder. Oh, it's a URI builder. URI. So this past URI scheme authority. What is authority? Authority is a byte string. Represents the authority component of URI. Component. From static. This function panics if the argument contains invalid characters is empty. Attempt to convert an authority from a static string. Yes. Yeah, it doesn't have authority. I think that HTTP is that what authority? Oh, username host. Get the host of this authority. The host subcomponent of authority is identified by an IP literal encapsulated within the square brackets. An IPv4 address is dotted decimal form or a registered name. The host subcomponent is case sensitive, insensitive. Okay, trust. The authority property is typically a server DNS host name or IP address. This property might include serving port number. Okay. For an example, write the host name as this and port number as H0. System.uri has host, authority, and DNS safe host. Authority is hostname plus port number. Oh, okay. Authority is this in this. And authority is this. Okay, hostname is this. Okay, that's what authority. Okay, why we came here? Yeah, URI has scheme. Scheme is the HTTP thing, right? HTTPS. This is what scheme. Okay, scheme authority, which include hostname plus port, path and query. Okay, that's what URI. Okay, going back to client. So we are using URI module in request. That's okay, and I just need to know where we using that. URI example execute request execute. Okay, send also should have client and hyper request builder places you are using URI. URI. Okay, all is this site implement futures implement pending. Ref. Yeah, it's all under client ref. Client ref can do pending request, implement pending request. Request pending request. Let's request. Super request. Request is from async impl. Okay, from here. Request pending request. How? Enum. Just, okay, pending request. Implement for pending request. Request builder. Mm, pending request. Request. Pending request. Pending request is a pin project on method. It's a, I think it's async. Yeah, same thing, but request doesn't have request is this time. Just want to see whether that request is referred. Yeah, it's an async struct. All the fields are there. How can they give it as a tuple? Pin and response future. Pending request. Okay, they are building all these future things for that pending request. Agree. Request. Is it possible? I just built a struct in 32 struct enum enum I32 name is test cargo build. enum. Oh, best enum request. It's never used. What is this? Oh, this doesn't need to be defined. Oh, needs to be defined. Entirely a new one. Okay, so this can be entirely a new request. Okay, I think we have gone through most some of the parts, but it's good to go through again through this code to understand more on the building blocks of request. So I think we have seen SRC, async bill, that's where the client RS is. That's where we have seen this hyper URI and hyper util and HTTP module as well. And configuration, this is where all the client builder configurations are set up. Okay, so this is we have seen. We didn't touch much on body. Yeah, a lot of pin project, pinning, a lot of async functionalities, so they need to pin. Uh, Stream. Request, did we see request? I think we have seen request. Yeah, request is where we have set up URI, URL method, header map. Yeah, I think we touched some of the basic building client code. Uh, let's see, we can go through some more modules in the coming videos. Otherwise, I think that's all I need to cover in this video. We will connect in the next one. Thank you.